Hello, welcome to Knox County School's Safe at Home video series, available to provide you with some guidance through the resource packets that are available both online and at our meal distribution sites. My name is Gary Petco, and I get to be your pre-K through 12 mathematics supervisor. And I get to speak to you as a 7th grade student, week 1, on the topic of adding and subtracting integers. Throughout our time today, what we'll first do is introduce the week's topic, what it is, where it came from, and when did you first learn it this past school year. We'll then provide you with some key concepts with examples to refresh your memory. Next, we'll preview this week's tasks that are included in your 7th grade packet, end with a weekly challenge, along with some available student resources that will give you some extra practice if you'd like it. As I mentioned, we're talking about integers, and it started in big part with this gentleman from India, Brahmagupta, born in the time of 598 AD and lived to 668 AD. Now, he's not the first one that really came up with the concept of integers. It was thought that the Chinese came up using integers way back in the BC area. But Brahmagupta was one of the first ones to really apply the applications in commerce and trade. We thought of fortunes and debts. Fortunes being you have money, debts is what you owe. Integer comes from the Latin word means tangerere, to touch. In, the prefix is negate, and I love to talk about the vocabulary that we're dealing with because I think that brings meaning to what we're dealing with. So integer comes from the concept of intact or whole, the entire part, what you can touch. It was early 16th century as an adjective meaning, as I said earlier, entire and whole, intact, whole, expressing the negation, the root tangerere, to touch. So what does that all mean? Well, if we look at what integers are, we know them as whole numbers and their opposites. -3, -2, -1, 0, 1, 2, 3. You've got your positive numbers, you've got 0, and you've got the opposites. So what does this concept of the negation of to touch mean? Well, going back to remember what Brahmagupta thought of in terms of commerce. We first had numbers because we used numbers to count things that we could physically see, that we could physically touch. But then all of a sudden, there were amounts that we could not see, amounts that you owe that were not there, or things that were taken away. So we had to have a way to describe them. And that came the onset of the concept of a negative number. And that's where integers derived and were first used in commerce and working with things that were being taken away. Now, earlier in the year, in Module 1, when you're in the classroom, you talked about adding and subtracting integers. It was probably around August, September. Some of the key concepts that you worked on was how to add integers with the same sign, how to add integers with different signs, and how to subtract an integer. Let's review what those key concepts were. Then we'll give you some examples before we start talking about the task. First of all, as a reminder, if you've got two integers, whether they're both positive or they're both negative, but they have the same sign, our goal was to add the absolute value of the integers and use the sign of the integers for the sum. So if you've got two positives, you take the absolute value of both of them and add them together and use that sign, that positive sign. If you've got two negative integers, you take the absolute value of those, and as a reminder, the absolute value, which is the distance from 0, that essentially becomes a positive value. So if we've got two integers that are the same sign that happen to be negative, their absolute values become positive. We turn them into positives and add them. We take the sign of the integers. But what if we have integers with different signs? So you remember what your teachers taught you is to subtract the smaller absolute value from the greater absolute value. And then the sign of the sum will be the sign of the add-in with the greater absolute value. And then what happens when we subtract? Well, the great thing about subtracting, we always think in mathematics, relate something new to something old. Something new, subtracting integers. Something old, adding integers. Well, if we can relate subtracting to addition, then we just keep the same rules. And our rules are subtracting one integer from another. Well, it's the same as adding its opposite. So if we can turn that subtraction expression into an addition expression by adding the opposite, then we fall back on the first rules we had in A and B. Now, as a reminder, when you're looking in your textbook, these are lessons 1.1, 1.2, and 1.3 in your textbook under Module 1. Let's look at some examples for this. That first example, A, -8 plus a -7. Those are two integers of the same sign. What we said was we find the absolute value of each of those numbers, each of those two add-ins. Absolute value of -8 is +8. Absolute value of -7 is +7. And we add that. But so the answer appears to be 15. But remember our rule, use the sign of the integer to write the sum. So whatever these two, the sign of these two were, that's the sign of our answer. Oops. So let's think about it. Sorry about that. I've got a debt of -8. Brahmagupta thought somebody owed somebody $8. So he has a net debt of $8. And all of a sudden, we get more debt. We get a debt of $7. What are those two debts together? They're a debt of $15. So if the signs are the same, we take the absolute value, add them, and our answer becomes a sign of the two original numbers. Part B, what if the signs are different? We have a -5 plus an 11. So somebody has a debt of $5 and then they gain $11, a fortune of $11. The rules were, we take the sign, we take the absolute value of both and subtract the smaller from the larger. So if I take the absolute value of -5, I have +5. The absolute value of 11 is 11, and I subtract the smaller, and I get 6. And the sign of my answer is the larger of the two numbers. 11 is a greater absolute value, so our sum would be positive. And part C, what if we're talking about the difference? A -6 subtract or take away 3. We said relate something new to something old. So as a reminder, we're going to take this subtraction and rewrite it as an addition by saying -6 plus the opposite of our second add-in. We're saying -6, take away 3, but now we're going to change that to a -6 plus a -3. And now our rules follow the same as it is in either A or B. These two add-ins have the same sign. So same sign, you just add the two numbers and keep your sign. So you've got 3 different situations. Signs are the same and you're adding, signs are different, or you're subtracting. Again, this was discussed in lesson 1.1, 1.2, and 1.3 in your textbook earlier in the year. That's what our task revolves around. Our task revolves around reminding you the concept of integers and how we work with operations. In your packet, you have 3 tasks that you could work on this week. These are tasks to keep you busy, keep your mind active. You can work on 1, you can work on 2, you can work on all 3 of them. We've also provided the answer keys so you and your parents can work through it together. The first task is called Spark Your Learning. And it's a contextual example, contextual meaning real life example. And the problem is a submarine was stationed 700 feet below sea level. Below sea level means something I can't see. That's a negative amount. It ascends 250 feet every hour. So keep in mind, think about what the word ascend means. Ascend means to go up. So we're below sea level, now we're increasing 250 feet every hour. Now, if the submarine continues to ascend at that same rate, when will the submarine be at the surface? So we're below the surface, 700 feet. We're going up 250. How long will it take for us to get to the surface if it gets 250 feet every hour? That's something you and your folks can work on, trying to represent that multiple ways, drawing pictures, using a number line, using our rules. See if you can write a mathematical sentence. Good practice on computing the sums of integers. A second task under your Spark Your Learning is when you're adding, subtracting a negative number on a number line. Because one of the things your teachers worked with you on was not only remembering the rules, but remembering different ways to understand the concept of adding and subtracting integers. Used algebra tiles, you maybe used a number line. this is going to have you practice using a number line. This task, under Spark Your Learning, has 3 scores of 3 contestants on the game show are shown. You got Morgan has 30 points, Carlos has 50 points, and Kaylee must be doing good because she's at negative 20. Must have missed a lot. The final question is worth 50 points. A correct answer adds 50 points to a contestant's score. An incorrect answer deducts 50 points, means takes away. What's your goal on the number line is to show the possible final scores for each contestant. What circumstances are necessary for each contestant to win? In other words, if Morgan started with 30 and she gets it correct, then what would be her final score? If she gets it incorrect, what would be her final score? What would it take for Morgan to have more points in the end than Carlos or Kaylee? Or what would it take for Carlos to have more points? Or actually Kaylee to end up winning, even though she's behind right now? So you've got 2 tasks under Spark Your Learning to work on, one on adding integers and one on using a number line to talk about adding or subtracting. A third task is available inside your packet. It's called a performance task. Now, I'll tell you right now, it looks like there's 7 questions on that task. But for this week, all you need to work with is problem number 1, number 2, and number 7. If you come back to us next week, we're going to work on 3, 4, 5, and 6, which is multiplying and dividing integers. But in this part, on problems 1, 2, and 7, you've got kites and fishing hooks. You've got a kite A, kite B, and a kite C, which has a height. Each kite is a certain height. The heights of the kites and the depths of the fishing hooks can be recorded using positive and negative integers and rational numbers. So we're going to hit some rational numbers, fractions. Use the table below to show your work. So you've got kite A is at 21 feet and fishing hook E is below the sea level at negative 7.1 feet. And you've got similar numbers for B and C. The question is going to ask you, kite A is at a height of 21 feet. If it ascends 15 feet, at what height is it now? Think about what ascends means as opposed to descend. 2, a fishing hook E is at negative 7.1 feet, meaning it's below sea level. It's going to descend another 3.3 and 25 hundredths feet. Now what would its depth be? So it's already at negative 7 and 1/10. And what if it ascends another 3 and 25 feet? What is its depth now? I'm sorry, I should have said 3 and 25 hundredths. Whew, messed that one up. And then 7, we're skipping to 7 because it's really interesting. See if you can write your own problem using the data in the table. Using any one of these numbers or sets of numbers, could you write your own problem? So you've got 3 tasks that you could work on this week. You've got your task on adding integers, you've got your task on adding, subtracting on a number line, and then the one on fishing hooks. You can work on one or all of them as you go through. Now, to leave you for this week, we got a weekly challenge. I love this. This comes from the Open Middle website. It's a great resource. It's free to use. Just Google Open Middle. And here's what it is. It's Open Middle because it's similar. It's kind of open to what you could put the numbers in. And here are your directions. Using the digits 1 through 6, at most, one each time. So use numbers 1, 2, 3, 4, 5, or 6, but you can only use it once. Fill in the boxes so that the top 2 equations are equal. Ooh, can you do that? So these top 2 equations, can you put the numbers 1 through 6 using each digit only once so that you would have the same result when you add? You've got a negative number, whatever number you put in there, plus a positive. Here you've got a negative number and you take away a number. Using those digits, can you create 2 equations that would be equal? And last, can you create one where the bottom equation has the greatest value out of all 3 of these? That's a tough challenge. So again, using the numbers 1 through 6, one at each time, fill in the boxes so the top 2 equations are equal and the bottom 2 equations have the greatest value. All right, so let's finish this week off with reminding you, if you need more resources to practice, visit our Knox County Schools website. We've got the web address right there. Knox County Schools website is knoxschools.org. On the front page, we've got a section for student resources. Got this blue arrow that reminds you to click on there where it says see all resources. That's where you're going to be able to find not only the information in these packets, but also more websites for you at your particular grade or grade level. Or if you'd like to visit maybe the high school resources or the elementary resources, they're all available. Whatever you do, just keep your math going. Mathematics is fun. It's out there. It's full of patterns. I just encourage you to look for it and have fun while you're out of school right now, out of the physical school building, but make your teachers proud. Do this mathematics, have some fun with the integers, and then we'll see you next week. Again, my name is Gary Petco, your pre-K through 12 mathematics supervisor, and I look forward to hearing how well you do. Take care and have a great day.